Well, good morning and good afternoon, everyone, and welcome to our field condition assessment webinar. I'd like to welcome you all. I see a few people are joining this webinar right now, so we'll give people a couple of minutes to come on. As we are going to present today, we have a few experts on the panel. My name's Eric O'Donnell. I'm the Managing Director of Sports Labs. I'm a civil engineer, and I've been working in sports surfaces since 1988 even, so it's a long time. I've got a co-presenter is Kieran O'Donnell. Kieran O'Donnell is the business manager for Sports Labs in America. Kieran's got a lot of experience with testing and consulting on artificial sports fields. And the chap that's going to do the heavy lifting today is Mark Corvas. Mark is our operations manager. Mark basically designed our field condition assessment process. So Mark could speak for many hours on this topic, but we're going to keep him to a tight sort of 30-minute window today. So I don't know if you want to flip the slides over, but I'm going to hand over to Mark, and please, you'll be muted. The videos will be off. Feel free to ask questions at any time on the chat. So just put the questions on the chat function and we'll collect up the best ones and we'll cover them near the end of the presentation. So I'm going to hand over to Mark now, and we'll take it from there. Thank you. So if somebody could flip the slides for us, that would be good. There we go.
All right, hello everybody. All right, so today we're going to go over field condition assessments, what they are, what the report consists of, and various tools we use in order to complete a condition assessment. So first off, what is a field condition assessment? We'll be looking at how this field performs, different characteristics, performance characteristics, how close to the end of the life is this field, and the information that we get from that and how to interpret it. So we use this in various ways. First, the main goal of it is to assess the life of the field, the extent of the damage, performance characteristics, and so forth. So this would be useful for folks who maybe they know that the field is at the end of its life. Maybe they still have questions as to how much life the field has left. And so we'll get to the bottom of that. So the typical report, we're going to be looking at safety. Safety is probably the most important aspect. We're able to measure that using quantifiable characteristics. Player interaction performance, these are also things we measure. We can use this report to look at future maintenance. What do you need going forward in order to keep the field either alive, in order to keep it serviceable, or perhaps we find that the field is no longer functioning as the field is intended anymore. And so in that case, now we're looking at the end of the life of the field. So we use a number of tools in order to do this. As you can see that we have our award-winning 3-in-1 device, which measures Gmax, AAA, force reduction, energy restitution, vertical deformation. We're looking at planarity. We're using tools to both measure quantifiable characteristics as well as observational characteristics, as well as various conditions of the fibers themselves. So how long does this take to perform? This should take us about 3 to 4 hours to complete the whole test, and the field is in use during the whole time by us. So it's ideally we don't have people on the field. However, usually we can work around things. All right, looking at the benefits. So first and foremost, like I said before, you probably already know if there's an issue with the field, but we need a way now of putting that into a report, having a third party verify these concerns, and we're looking at identifying the safety, which translates then to liability. So reducing liability. If you have safety issues, people are getting hurt, whether this is impact safety issues, whether this is tripping hazards with open seams, we really need to take a look at that in order to keep the field as safe as possible. Later on, we're able to provide planning for the upgrades and repairs. So perhaps this field isn't at the very end of its life, but we're looking to get one more year out of it. And so we're looking at how do we proceed with that, looking at what sort of repairs or upgrades you might need for the field. And then where this really comes in handy is securing funding for a new field. So oftentimes you're going to need evidence in order to provide the necessary information to the folks who control the money in this whole situation, right? And a lot of times, you're not able just to say, hey, you guys, we need a new field. We'd like you to, put a proposal together. You'll need some data to back it up, as well as other information. So who is this for? So design consultants, architects, for example, maintenance contractors, turf manufacturers, and field owners. So perhaps you're a maintenance contractor. You also bid fields. You come across a field that is definitely towards its end of its life, and you say, well, hey, let's gather some more data. Let's gather some more information on this field, put a report together, and we can really potentially use this to make the case for a renewal. Manufacturers as well, they know what fields are towards the end of their life as well. Perhaps we need some data gathered to really get a good look at things. And then especially field owners. Field owners know their field better than anybody else. They understand that perhaps their field is in bad shape. But again, they need the information and the data to back up the necessary paperwork that it takes to get the funding. All right, so within the report, let's take a look at what's inside of it. So there's three main characteristics here. Data collection is the big one. So this is where we're able to get quantifiable measurements, performance, safety, measurement data. So this is primarily a data-backed conclusions for these results. The next one is visual defects and observations. So we're able to look at all sorts of different aspects of the field, whether it's the fiber condition, damage, planarity issues, and we map these. So we make it as clear as possible when presenting. And finally is the easy to interpret results. So we've identified the need to be able to communicate these results much easier to the people who are the end users. So oftentimes you're communicating this information to a city council, a municipality, or a school board, for example, and we need to make this interpretable to somebody who doesn't know anything about fields at all. These folks understand they might have a field, but they don't know the first thing about artificial turf or the types of things that we're measuring. So the main goal of this reporting style really is to make this easy for everybody to understand, because not everybody is an expert. So within our data collection, the types of things, we already went through the tools we use, but just to reiterate, GMAX for the American market, HIC. So these are both impact related measurements that we're taking. This is going to be most most applicable to safety. So head injuries, obviously, GMAX, body injuries. We look at the artificial athlete. And so that's your force reduction, vertical deformation, energy restitution. Those are more player interaction involved, although they do translate into safety as well in certain cases. Ball roll and ball rebound. Especially soccer players, you'll know that a field with laid over fibers, a ball that doesn't respond off the surface properly, that's hugely important for the game. And so we'll be looking at that as well. Rotational resistance, which is traction. Once again, that's more player interaction with the field. However, it's also important for safety. And then related to the fibers, the field itself is your infill depths and pile height. So these are all things that we measure and are quantifiable. Our visual defects, now these are important. We're looking at fiber condition, the way that the fibers are laid over, the way that they may be split at the ends, the infill on the surface, if there's distribution issues, if these fibers aren't able to hold infill anymore, then you'll find that there's infill on the surface. Seams and lines, as fields age, the seams weaken, they open up. We're going to want to be able to document and note exactly where those are at. The overall wear patterns, you're going to have different sort of conditions right in front of the goal box compared to the sidelines. We want to see where this is wearing the most. Here I have a baseball field example. If you've been on those, you know exactly where those have the most issues. And then noted the defects and damage. So this is where we're going to map this for you all over the field. You know exactly what the defect is, where it is on the field, and then you'll be able to present that in a report that's comprehensive and easy to understand. So let's go on to the conclusions here. If you can see the screen, we have these results presented on a slide scale. So red meaning bad, green meaning good, obviously, yellow meaning an area of concern. We're able to demonstrate these results using, we've got the minimum result, the maximum result, and then the mean as well. So just at a very, very quick glance, you're able to see where these results are trending, where it's averaging, where you have your worst result. And this is important because, again, we're trying to communicate this information to folks that may not fully understand what any of this means. And so at a glance, you're able to see where that trend is. Below that, we'll have the definition of the test. Once again, folks aren't going to understand what exactly this means. There's a pretty concise, easy to understand definition below that. And following that is a conclusion where we're able to kind of wrap it all up and explain this is really what you're looking at with the condition of your field here. Also noted is that these conclusions are based on the results. So this is an opinion. We're looking purely at the results here. Below this on the screen also I have an infill depth map where we're able to kind of colorize where you have high spots, low spots. Again, easy to see where we have affected areas with low infill or perhaps overfilled infill. All right, I'm going to turn this one over to Eric actually for what we get from these, how to use the reports. Are we able to do that now?
Okay, thanks, Mark. I hope everybody can hear me. So it's our clients. It depends on the type of client that really is looking for condition assessments. We do. Mark didn't cover the. We are even asked to go in and assess a new field because there may be an issue with it. It could be that the install's not been up to the required standard, or there may be latent defects in the materials that have been supplied, stripy turf, loose fibre, or loops in the fibre which are causing a hazard. So if a client, we do a lot of end of life type assessments where the fields are coming to the end of their life, and there needs to be a benchmark on how many years you might still get out of the field safely, or is it actually worn out and it needs to be replaced, so funding needs to be secured? But similarly, and nowadays it's a very, very competitive market out there. You do see, I wouldn't say cutting corners, but practices that lead to some defects being incorporated in the install at the very early part of its life. So these are quite challenging assessments to do, because there's always a lot of money on the table, and a very emotive position from either a client or a contractor or an installer. So these reports, I mean, from dialing in the maintenance that's required on a field, where we may do an assessment 4 or 5 years in, and the field's lost its infill, the fiber's beginning to fold over, and there's other issues with the field where there might be some seam issues or inlays are coming loose. The report's used to bring the maintenance up to the standard required, get the field back to A1 if you can, and then the field can be used safely thereafter. Where it's maybe an end of life, or where the field's being set up for refurbishment, it's really just reporting on what the issues are, trying to eke out another 12 months or 18 months from that field. Where we go to fields that are 14, 15 years old, no amount of maintenance or tender love and care is going to bring that field back to life. And it's more about, what are the liabilities with this field, and are you doing a risk assessment on it to see what you might end up with if somebody gets injured, or if it's not safe. These recommendations, usually there's quite a discussion that goes on when the report is published, because these things, data is not always easy to interpret. Mark's made it clear that the reports, there's colour coding, there's also other additional information about what the test actually tells you provided in the report, if you're a lay person or an owner that is not familiar with testing. So there's other elements to the report that help you interpret it, but ultimately you probably need to sit down with us and discuss the findings, so that we can make the recommendations that are dialed into your actual field. I mean, every field's unique. There's always about 3 or 4 things that are going on in a field, sometimes 20 things, and it's our job to bring that all together in a neat set of conclusions that allows you to take it forward, with whether it's a maintenance issue or a replacement issue. So that's how the reports are used, and that's how we deal with our clients. I mean, maybe Mark, you could say something about some of these contracts where a client has got many fields to assess. So we've done a couple of fairly significant jobs where a client said, I've got like 20 fields under my ownership, and I just need a benchmark on where we are with these fields. I mean, that's a really challenging project to look after, but also fascinating to see what's happening in the network with municipalities and local authorities.
Mm-hmm. See if I switched over. Okay. Right. Yeah. We have taken a look at for large municipalities, especially where they may have 10, 20 fields, and we'll spend 3 to 4 hours on each field, and each of them might be in a completely different condition. So we're able to look at every piece of that field and really get an idea for, is this field in a good spot? Does it have 5 years left of life on it? We can't really say how many years left, but you can get an idea. Then there will be fields that are towards the end of the life, and then there's fields that are certainly need to be replaced immediately. And then we also have individual owners that really want to get an idea for their field as well, where it might be just a single field. So it's a wide range of customers that we look at for this. Like I said, could be one field, could be as many as 20, and all of them are different, and we're able to get a good benchmark on what the condition of that field is, and then later on down the road, perhaps we do this again, and we look at how it's aging over the years, getting a really good idea for how things are going.
I've got another question for you, Mark. You highlighted the criteria in the report there. So if you put the report back up, you've got some numbers there: shock absorption, vertical deformation, energy restitution, and you can see there's limits applied. Now, I think it's easy for us to look at limits for physical tests like that, where you're actually using a piece of equipment. Where do these criteria come from?
Right, so the criteria comes from, it borrows a little bit from FIFA, a little bit from World Rugby, but primarily from the one serve concept, which is the United States' adaptation of those other governing bodies criteria. So we have the limits posted there, numbers wise, as well as the mean. This will also come with a table with every single test location will have the information. So this what you see on your screen there is just sort of snippets of parts of the report, and then you can see with the criteria there on that scale, with the minimum, the median, the mean, and the maximum result.
So Mark, so we've got the actual physical test, shock absorption, so a player surface interaction test. We've got numbers that are 55 to 70. So that criteria, that's being taken from a tried and tested standard that's out there. I think the FIFA standard was brought into play in 2001, so it's been around for a long time. And then we've got the physical number that you've measured on the field, and that number's 47, so it's lower than the lowest limit, which is 55. So that's not good, is it?
No, it's not. And like you said, this was established. These limits are established by international governing bodies, and so yeah, tried and tested. And then looking at that scale there, it's easy, just at a glance, it's very easy to tell. All your results are trending towards a very, very firm result, which is in the wrong direction. And so, yeah, very easy to tell at a glance.
So these physical property tests would be tending towards saying, well, it might be a safety issue, or it might be a player performance issue, or it could be a ball surface interaction issue. But these physical tests are telling us, factual information about the playing surface, and your color coding there is more of a sort of indicative. Yeah, it's sitting in the middle, or it's tending towards being, on the firm side, or the bad side, or the good side of these limits. Yeah.
Right. And you have to consider who's actually using these reports. So we're putting them together, and this is going to end up in the hands of, like I said, it's going to be a school board, it's going to be a city council, it's going to be somebody that isn't familiar with this at all. And instead of playing the telephone game where the owner calls us or somebody calls us and we go through a whole discussion, which we should do anyways, we're able to bring you a report that's just easy to understand right off the bat. So nobody has to be an expert. We don't need to go through a whole class of how to know what shock absorption is or HIC. We're able to give you a nice comprehensive report that, with color coding that shows, is easy to see, where your field stands.
And Mark, did see the criteria? Originally, I think FIFA and some of the other governing bodies were looking at the best natural turf and stadiums and trying to use them as the benchmark for how we would regulate artificial fields. Is that what we're trying to do here? We're trying to, benchmark against these stadium turf fields, as it were.
Right, correct. So the criteria were developed based on testing on the perfect natural grass fields. So um, maybe 100 fields were compared, perfect natural grass fields. This data was collected, and then that's how we determine that's the criteria we use for assessing these artificial fields now. Um, and so all of this is based off of what an optimal or close to optimal natural grass field is. So that's what we're comparing all of this against.
Okay, and let's look at the fibre now then, because that's a very interesting, because we're not, it's less easy to do physical tests on the fibre. These are probably slightly more subjective assessments that we do, but equally very, very important, because when you say, the fibre's folded over, or it's splitting, fibrillated, or it's in fact breaking off, these are all very important when it comes to determining, how long you've got left from a playing perspective on that field. So how do we go about, assessing the condition of the fibres and even the infill, etc.?
Right, so we have a pile height indicator. I believe that was over on slide 1 or 2, but we're able to measure how high those fibers are against the infill. So how much fiber do we really realistically have left? That's important for a number of reasons. For ball interaction is one of them, and then safety. If your fibers don't have enough fiber left in order to retain any infill, you're going to have issues where the infill is sitting on the surface. I think there's a photo down there as an example. That can cause slipping. You won't have any traction on that. The conditions of the fibers themselves, you'll see them flowering at the end. And then comparing the different fibers as well, you'll have multiple different colors of lines, especially on fields in the United States where you try to fit 5 or 6 different sports onto one field. Those fibers will degrade at different times. So now are you seeing a situation where half the field is disintegrating while a little bit of it is holding up? And then are the fibers even effective at a controlling ball roll, for example? So it has a gameplay sort of aspect of it too, not just the durability. So when you start to see issues where fibers break off easily, they no longer retain infill, they're flattened. That's really edging towards the end of the life, and so we're looking at how that affects the infill as well.
Now, many fields are you seeing the seams, the lines, and the inlays coming out? Is that quite a common thing, or is it? I'm just speaking towards the quality of the installation and the durability of these. So I've seen a field, I think, that had 11 different line markings on it in a school, which is just, it's a crazy sort of situation where you're cutting turf with 11 line markings of different colours,
Right, yeah, and a lot of that's going to depend on the climate you're in too. Fields in Arizona are going to be different than fields up in New England, and just by the fact of what the sun does to these fibers, they degrade at different times. A field in Arizona might be treated a little bit different than a field, up north. And so, yeah, you're seeing conditions on these fields where the lines are degrading quicker, or fiber loss is at different rates. And then you end up getting a lumpy field where, balls are skipping over lines that haven't degraded, or retaining infill. Issues where seams are coming apart, where that line is meeting the main turf. So there's all sorts of different things, and I think I might have a photo up ahead. Yeah, right there. You can see in one of these photos here, you can clearly see the seams coming apart, and a number of different lines there as well.
Yeah. And I want Mark, there's obviously this is a protocol that you have put together. So have you ever worked out how many actual tests and assessments you do on a surface? I mean, it must be literally hundreds of points that you're measuring on a field when you go out and do these field condition assessments.
Right, yeah, and especially when it comes to planarity, I think this middle photo you see here, as we're doing planarity, which is where we're searching for high spots or low spots, we're covering every single square inch of the field. So we're not just walking around and picking up little things with our eyes. We're we've got eyes on the field every square inch as we're dragging that bar. As we're dragging that bar, we're also noting things like tears, rips, any sort of damage, low infills, high areas of infill. Looking at where the seams have come apart, or where inlays have come up. On football fields, it's really common where on the hash marks you got corners coming up left and right. And so this is all being mapped. And again, to make this easy, not just to show where the affected areas are, but say, for example, we're now using this report as use for deciding how to go forward with repairs. The repair guys are going to want to know where those are all at. And so we're going to have this mapped out nice and easy with all the points included on that map. And so you can see exactly where everything is.
Okay, thanks for that. And see, with the report, Mark, I mean, take it you come back to the office, you've got to look at the results, make your conclusions. I mean, what's the sort of turnaround times from doing a condition assessment to getting the report out? Is it a couple of weeks, or
we try to keep it to about a week. Depends on the load in the office, of course, but the reports take almost as long to do as the actual testing itself. And so that's how much care and detail we're putting into this. And it's all the work to make this easy to understand. So yeah, the turnaround time, we're looking at about a week in general, but we try to get it out as fast as possible.
Yeah. I think we need to bring Kieran in here because he's looking quite serious on my video screen anyway. Kieran, so how many is this taking off now with clients in terms of, we are seeing the market changing a little bit, and the refurbishment of older fields is becoming a major part of the market as replacements find a big piece of the pie. How much take up are we getting from consultants, engineers, and even owners out there in the marketplace?
We're seeing a large pickup. Hang on, sorry, I just got some feedback there. We're seeing a large take up on this sort of request for information or reporting, because people are looking at trying to either extend their lifespan of their field, or looking at if their maintenance is working, but also being able to take this to a board and say, look, we need to start getting some funds together for the replacement is a big part. People need to start planning for these replacements a lot earlier. And this is giving them information or the tools to actually start that process. It's not always just about, right, we're going to put a field in this year. It could be a couple of year process to sort of start that conversation, especially with a lot of these public bids, the public money. It can't just happen overnight. So we're seeing a massive uptake in it. We're also getting feedback from the industry that they like the simple to read tables, the way that the information is presented, so they can take it to the owner. Like the biggest compliment we've had so far is they can take this to an owner, sit down with them, read the report, and actually go, right, we need to do something, or we need to increase our maintenance. Or because it's not always about saying the field is at its end of its life. It could mean, look, we need to invest some more money in maintenance. We need to add some infill. We need to have a proper crew out there to maintain this field to get us that extra 2-3 years, is what the owner needs from that field. So I don't think we should be scared from this data. We should use it to our advantage and make sure we put things in place to either extend it or start that conversation about replacing.
Okay, thanks for that, Kieran. So at this stage, I don't know if we've got any chat questions, because we're all in different rooms, Neil. I'm not sure where we can, I can't see the chat on my feed here. But is there any chat coming from the floor at all? Any questions or?
Yes, Eric, we've got one in from Max that's asking about the test locations. How many test locations do you do for AAA? But it's probably a good time to shout out to the audience that there is a Q&A function. So on your phones or on your device, you can put the questions in for any of our team members, and they'll take them as we go.
Okay. So Mark, you want to answer that one then?
Yeah, so since this is being developed in the American market, we've taken GMAX locations. So the GMAX is one of the required tests, obviously, and so those locations seem to be most advantageous and more familiar for the end user. So we'll do 10 test locations of each test, except for ball roll. That one will be the standard 6. Yeah, so 10 test locations of each one. It's important to note too that these tests can be modified per the user's needs. So if you want full 19 or 23 test locations of AAA, if that's your concern, we can always make that happen. If, for example, ball rebound is something you're not interested in, we can drop that, or beef up test locations for certain things that you really are concerned with. So it can be modified, but for the standard test, we typically go with the standard 10 GMAX locations.
Good.
There's another question in for you, Mark or Kieran, throwing you under the bus here. Costs for test and reporting. Is that something you can take today?
Yeah, go for it.
I guess a lot of these come back to volume, doesn't it? It's how many fields, where they are. So Kieran, you probably have a better position.
That's always a bit of a loaded question when it comes to costs. We've been able to keep the costs down. I won't say exact numbers, just to be a bit more educational on that. But it's a very it's a cost. Like the cost is not much at all to get the amount of data. And look, we're living in a society or a time where data is king. We need this data to actually make decisions and be able to forecast what's going to happen. So getting this data, I don't think there's a price you can put on it, but it's not going to break the bank. We're looking at a very cost-effective way to get a good assessment on your field, even to the point you could almost be doing that assessment every year without breaking the bank. With our technology, with our testing equipment that we've developed and won awards for, and the way that sports labs technicians work, we can get field tested, like Mark said before, in a couple of hours, and do either sort of 2 or 3 a day. So it allows us to keep that cost down and keep the guys busy. So Bob, if that's a question you want a hard answer on, feel free to reach out afterwards and I'll give you the exact number.
There's a great question. How do I know when I need a field condition assessment done? So there you go. So if you think you need a field condition assessment done, you probably do. If that's what you're thinking, because you must be seeing something on the surface or signs on the surface that you're worried about. But it can come in many ways. I mean, sometimes it's just feedback from the playing community that says, "Oh, that's something wrong with that field. I don't like it. I got injured, or I'm falling over all the time." I mean, we do watch some of the major competitions that are held on artificial turf, particularly in the NFL, and you do see some. I think early in last season there was a lot of players falling in one particular field, and that would ring alarm bells if different teams are experiencing the same problem on one field. Then we'd be interested to do some testing on that field. But generally, it's signs like failures of line markings and inlays, or the yarn fibre begins to look as if it's breaking up, or it's shedding, or there's tripping hazards on the field. It's become very irregular, bumpy, or seam failures, things like that. These are the sort of signs that start to tell you that you need to do some sort of assessment. And now we've developed this fairly sophisticated set of tools, but walking over the field and looking at it just visually is a very good start in the process to say, yeah, I need to bring in a testing lab or an expert to do a more formal report, so that you can take that to the owner, the board, whoever you're reporting to. If it's a facilities management person, then they need these tools to then go back to their board to get the funding to do the work that's required, whether it's intervention maintenance or upping the frequency of maintenance or buying new kit for doing the maintenance. That can be an end game here, or it might be that we're trying to demonstrate that the field is needing replaced, and it's T minus 12 months. You need to raise the funds to get that field replaced the next summer. So that's probably not answered the question, but that's how we approach, you know, providing that recommendation. I'm getting a lot of WhatsApp messages here, so I'm not seeing them on the chat, but is there any other questions, Neil, that we've got coming through?
You've got one here about maintenance. Just asking the frequency of maintenance and how you basically align that with testing. So I guess it's coming back to hours of usage and how often you should be doing these assessments.
Yeah, I think maintenance is, you know, you dial in maintenance based on the manufacturer's recommendations. So the supplier of the turf has got a very, you know, formal maintenance recommendations, and that's what you've really got to follow to protect your warranty. But then the number of hours of use that we are field is experiencing may mean that the frequency has to be increased, or the type of equipment that's used or the intervention that's used has changed. Decompaction and then moving infill around can be major issues. But also nowadays we are seeing more and more systems that are not rubber crumb based, and the maintenance on some of these organic or alternative infill systems is different, and it may even mean that you need different equipment to do it. So yeah, it's fairly dynamic as we see more and more infill types coming to the market. You know, we've got to keep ahead of that as well and educate ourselves on, you know, what needs to be done so we can make the correct recommendations. So I think frequency of maintenance and the type of maintenance has really got to start with the manufacturer, and then we work back from there, you know.
There's a question here that's come in regarding basic self-assessment kit. So what should people use in terms of really basic self-assessment kit on site?
Interesting question. Kieran, you want to answer that one?
Yeah. So I think for self-assessments, an infill probe, a pile prism, and probably a ball ramp is the best place to start, because that way you can be checking your field on a regular basis, or the surface on a regular occurrence, because they're the ones that you can do quite quickly and easily. You don't want to be taking up too much time. You can look at buying your own GMAX machine and HIC device, but once again, that comes at a bit of a cost, and can start taking up a lot of time to be out there. And a lot of these facilities that probably need these condition assessments probably don't have the ability to be testing these fields on a regular basis. But a ball ramp and an infill probe is very cheap to get and very repeatable, and you can get out there and get that data. That's probably where I'd suggest people start.
I mean, it is the case, Kieran, that we
just saw one question come in from Nick as well about, do we cover all the US when completing assessments? Yes. Yeah, we sort of work all in North America, coast to coast, covering the whole country, and we've got technicians live on the West Coast and live on the East Coast as well. So we're able to cover the whole country at quite an easy ability to do that.
Sorry, I was going to say, Kieran, that is, we obviously the self-assessment process is very common on natural turf, and we've got kits that we've designed for groundsmen and grounds care staff to do a little bit of assessment themselves, so that they can feed back to us or even the managers or clients on the performance of natural surfaces. So it's interesting to see that might be, we know that FIFA recommend that or insist that you have ball roll equipment and pile height depths and things like that when you certify a field. But it's been interesting to see that question coming in on the artificial field side, you know.
Got another quick question, guys, came in, and it's about where you guys are located. So maybe give an idea of East Coast, West Coast.
I guess thought we just covered that, but yeah, so we've got technicians in California, Washington State, Florida, Tennessee, and one in Missouri as well. So we're able to cover the whole country quite well with the way that we work in our equipment. Like I say, that field marshal device that we've developed is sort of a game changer. We can actually get to many more fields in the same day. It makes work for the technicians a little bit easier. They actually quite enjoy using that compared to the other devices. Instead of going through airports with 5 or 6 bags, they can actually now travel through these airports with a couple of bags and get on and off fields much easier. So that's probably one thing Sports Labs prides itself on. It's its investment in the testing equipment and the technology to sort of keep us at the forefront of the testing industry, because we want people to be able to get this data. Like, more data is better. Like, we can make much better decisions if we have the data behind us to make these decisions, and that's where we need to be getting to, is collecting this data. And unfortunately, in the past in the US, the GMAX machines just not giving us enough. It just doesn't give us enough information to make those decisions correctly. So now, moving forward, we're in a position where we can gather this data and actually make an intelligent decision.
Got any other questions coming from the floor at all?
No, most of them are coming through the Eventbrite platform, Eric. So none on this platform at the moment.
Right. So we can't see the Eventbrite ones, no?
Yeah, we're ticking them off. We've covered them so far.
Okay. Something for the next webinar, shall we say? So okay, well, if there's no more questions, I think what we'll do is we'll probably wrap up. But you know, this has been recorded, so we'll put the recording on the website. So if anybody that you know wants to see this, you can maybe let them know. We'll still take questions. If you want to email in a question, just get in touch. It's no problem. Got any questions about the process or the reporting, or even if you've got a field that you're worried about and you want to ask questions about that, we won't charge you for a phone call, I can assure you, or Kieran won't charge you for a phone call. There's the contact details up there. We will put something out on after the webinar that you can give a bit of feedback on. But yeah, if there's no more questions, I'd like to thank Mark particularly for putting the presentation together and for all the work he does in bringing this really unique and innovative tool to the marketplace, and for presenting today. I know Kieran for your input as well. Thanks very much. And Neil and Dane producing it in the background with all the technology hiccups that we always get with these things. You think Microsoft could get Teams fixed by now, but you know, we live and learn and hope. So thanks guys, thanks everybody for attending, and we'll see you soon hopefully.